Welcome back. Today I'm going to be going through an introduction to probability. So, the key concept here is that basically the probability of event A occurring is equal to the number of favorable outcomes. So, essentially, the number of ways that outcome A can occur or that event A can occur over the total number of possible outcomes that occur, whether or not they include event A or not. So let's go over two examples here. The first one says, you roll a six-sided die. What is the probability of A rolling a 5, B rolling an odd number, and C rolling a 5, 6, 7, or 8? So the first thing I'm actually going to do before I answer this is I'm going to write down the sample space. So the sample space is basically a list of all the possible outcomes. In this case, all the possible outcomes are equally likely. If I roll a six-sided die, we could end up getting either a 1, a 2, a 3, a 4, a 5, or a 6. Those are the options. And so therefore, there are 6 possible outcomes when it comes to rolling a six-sided die. Any of these are the possible outcomes. So to answer part A, which asks the probability of rolling a 5, well, there's one way to roll a 5 since there's one 5 on the six-sided die. And then over the total number of outcomes, there's 6 outcomes in total. So the answer is 1 in 6. What about for B, which asks about rolling an odd number? Well, let's count how many odd numbers there are in our sample space. Well, there's 1, 3, and 5. These are all odd numbers. So there's 3 odd numbers out of a total of 6 possible numbers we could get, a total of 6 possible outcomes. So the probability of rolling an odd number is 3 out of 6. Now 3 out of 6, if we divide numerator and denominator by 3, this reduces to 1/2. So half the time we will get an odd number, the other half the time we will not. We'll get an even number. Then for C it says rolling a 5, 6, 7, or 8. Well, 5 would be a favorable outcome, and it's right here on our die. 6 also is a favorable outcome, and it's on our die as well. 7 and 8, although they are like favorable outcomes in terms of the probability question, they're actually not possible to do. And so we don't need to include them here because it's not possible to ever roll a 7 or an 8. So the answer for C would be 2 out of 6 because 2 of the outcomes out of the total of 6 would be either 5, 6, 7, or 8. Really just 5 or 6, right? Because 7 and 8 aren't there. But there we go. Then I'm going to reduce this as well. If I divide 2 and 6 by 2, I get that this fraction is equal to 1/3. Reducing fractions is a good practice in general, although I will say in terms of probability, it's not as crucial that we do it as it would be in other units, but I will still be doing it for today. Let's try example 2. An urn has 3 red marbles, 4 blue marbles, and 7 yellow marbles. If Sarah randomly draws 1 marble, what is the probability of randomly drawing A, a blue marble, B, a marble that is red or blue, C, a purple marble? Okay, so let's start with A. What's the probability of drawing a blue marble? Well, first of all, how many blue marbles are there? There's 4 blue marbles, so 4 is our numerator. And then the denominator will be how many total marbles are there? Well, there's 3 red, plus 4 blue, plus 7 yellow is equal to 14 marbles. And so therefore, the answer is there's 14 marbles overall. So the probability is 4 over 14. Now, if we divide both by 2, we get 2 over 7. Next, we have B, which is a marble that is red or blue. Well, how many marbles are red? That would be 3. How many marbles are blue? Well, that'd be 4. So 3 plus 4, because any of the reds or any of the blues would be a favorable outcome. And that's over the total of 14. So therefore, it's 7 over 14, which if we divide both those by 7, we get 1/2. So therefore, half the time, Sarah continues to do this, approximately half the time, she should end up with a red or a blue marble. Then we have C, which is a purple marble. How many purple marbles are there? Well, there's 0, because it's not possible to draw a purple marble, over a total number of 14 marbles, and 0 over 14 is just 0, so the probability is 0. And that actually kind of brings us to another point that we'll talk more about later in a future video, which is that if an event is impossible, if it's completely impossible for something to occur, that means the probability is zero because there are zero favorable outcomes in that case. As always, if you have any questions, feel free to leave those down in the comment section, and we'll see you for the next one.